Space on the central coast of California. I'm NASA's Megan Cruz, and you are watching the pre-launch news conference for SWOT. SWOT is the surface, water, and ocean topography satellite targeted to lift off tomorrow, December 15th at 3:46 a.m. Pacific time atop a SpaceX Falcon 9 rocket from Launch Pad 4 East here at Vandenberg. The launch will be managed by NASA's Launch Services Program. SWOT will survey nearly all water on our planet's surface for the first time ever. This global inventory of our water will help scientists better understand where the water is, where it's coming from, and where it's going. These observations will provide insights into how the ocean influences climate change, how a warming world affects lakes, rivers, and reservoirs, and how communities can help better plan for disasters like floods. SWOT is a joint mission between NASA and France's space agency CNES, with contributions from the UK and Canadian space agencies. To tell us more about this mission, we have a distinguished panel gathered here for you. To my far right over there, we have Karen St. Germain. She's NASA's Director of Earth Science. Next to her, Tim Dunn, Launch Director, NASA's Launch Services Program. Juliana Scheiman, Director of SpaceX's Civil Satellite Missions. Parag Vazay, SWOT Project Manager, NASA's Jet Propulsion Laboratory. Thierry Lafont, SWOT Project Manager with CNES, and Captain Max Rush, Launch Weather Officer, U.S. Air Force. Now, each will deliver some opening remarks, and then we're going to take questions from reporters. Anyone in the room here can raise their hands, and those on the phone, they can get into the question queue by dialing *1. Those on social media can post their questions using hashtag AskNASA. Okay, so with that, Karen, go ahead and kick us off.
Great. Thank you, Megan. So many people don't know that the planet that NASA studies the most is our home planet, the Earth. And in the video, I think we're going to show here in just a minute, we have a fleet of 25 missions that today are looking down at the Earth, trying to understand how the Earth works as a system, and observing ice and water and land and the atmosphere. So we're anxiously awaiting the latest addition to our Earth science fleet. This will be the SWOT mission that will be launching tomorrow morning. So Earth is a water planet, and SWOT will bring us a revolutionary advance in our understanding of how water moves around our planet. And it starts in the oceans, it gets delivered to land through the atmosphere, and eventually returns to the oceans. That's the water cycle. And as our climate is changing, the water cycle is amplified. So SWOT is going to give us a very high fidelity understanding of how water is moving around the planet. We're building, of course, on a 40-year partnership with CNES in advancing the technologies, and again with contributions from the UK and Canadian space agencies. And this new technology will give us 10 times improvement in the fidelity, the spatial resolution, in our measurements of water height. This is important because as the climate warms, oceans are rising, our coastlines are changing, and we're seeing large fluctuations in inland water bodies, lakes, reservoirs, and rivers. From a scientific perspective, the measurements from SWOT will help us really understand how this water cycle is changing and the critical role the oceans play in climate change. From a user perspective, and this is one of the things that we're most excited about, the data from SWOT will inform communities around the world, from water managers and agriculture producers inland to coastal communities who are dealing with increased risk of flooding and disaster planning and preparedness. Another exciting thing about SWOT is not just what we're doing, but how we're doing it. We will be sharing the data from SWOT broadly and freely to people around the globe who can use it to inform their decisions. And this will happen just a few months after we are also building tools help people make best use of the data. So really exciting mission, incredible advances in science, and we just can't wait. Megan.
SWOT's going to accomplish a lot, so we can't wait to see it launch. And with that, why don't we go to Tim?
All right. Thank you, Megan. So I'm proud to be here today representing the women and men of NASA's Launch Services Program. And I'm also very proud to be the NASA Launch Director for this incredible mission, SWOT. I'm very excited to be a small part of a very amazing team that's represented here today. SWOT is the 6th NASA science mission that we will launch on a Falcon 9 rocket, and it will depart Earth from historic Slick 4 here at Vandenberg Space Force Base. I would like to recognize the 9 SWOT launch team, SpaceX, NASA, Kinéis, Thales, and the U.S. Space Force's Space Launch Delta 30. This assembled group of professionals is exceptional, and I would like to take a moment to give you guys a peek behind the curtain. So we represent each of our organizations, but if you guys could see what goes on behind the scenes with the teamwork involved, with working with Karen's team at headquarters and Parag's team at JPL, and then obviously Juliana represents an incredible launch vehicle team at SpaceX. It's just amazing how we're able to bring all of this together, this SWOT capability to all of us here on Earth. So we get to see that every day in what we do, but I just wanted to have a moment to share that with you guys. And one other personal item, I'm the launch director for this mission, but I by far don't do it alone. I have an incredible team from LSP, but there's one individual that this will be his last LSP mission, and that's our LSP senior launch director, Omar Baez. And Omar, I know you may be out there watching. You've meant so much to me. You brought me into this role over the past decade plus, and if many people have worked with Omar and know him, he's incredible to what he's brought to LSP and how he has steadied our launch team for so many years. We're going to miss him when he retires in February, but don't go far. I'll be picking up the phone to call you often. All right. So the integrated Falcon 9 team has been busy with final launch preparations. Last week, we encapsulated the SWOT spacecraft inside the payload fairing, and we performed a successful mission dress rehearsal. Just last Friday, the combined launch team held our flight readiness review, and then later that same day performed a static fire with a successful 7-second static fire lighting of all 9 of the Falcon 9 engines. Subsequently, the rocket was returned to the Slick 4 hangar where the SWOT spacecraft was mated on Monday of this week. Now I'd like to show a video of the launch team's efforts here at Vandenberg to get us ready for this launch. Please roll the video. Okay, here you see a 747 bringing a lot of ground support equipment for the SWOT spacecraft from Europe, where it was manufactured. And so this all occurred a couple of months ago in October, right here at Vandenberg. And there is an Air Force C-5 bringing the actual SWOT spacecraft. There's SWOT in its shipping container coming off of that C-5 aircraft. Many thanks to the Air Force for allowing us to use that aircraft to transport. And here is SWOT unveiled in the Astrotech facility on North Vandenberg. It's just a gorgeous spacecraft. And then after we processed on North Vandenberg, we put it back in its shipping container and brought it to South Vandenberg to Slick 4, and there it is going into SpaceX's payload processing facility at Slick 4. There's a great still photo of SWOT unveiled in the PPF at Slick 4, and there it is about to be encapsulated with the payload fairings on either side. Okay, so here is some footage from the past. This is a couple of years ago when we rolled out Sentinel. But this is what it looked like yesterday as we rolled to the pad to get ready. We went vertical overnight, and we're sitting out on the pad getting ready. So yesterday we did also hold the Space Launch Delta 30 Launch Readiness Review, and we followed that with the joint SpaceX-NASA LRR, where we received approval from senior NASA, JPL, SpaceX, and U.S. Space Force leadership to continue processing toward launch countdown. You saw in the video representative rollout. That did occur yesterday, and we are now vertical on the Slick 4 launch mount. We are performing a few additional inspections of the rocket today that Juliana will tell you a little more about. So early tomorrow morning, the launch team will arrive on console to perform final pressurization and launch vehicle checkouts. The launch team will be polled around 3 a.m. Pacific time for concurrence to load the Falcon 9 propellants, RP-1 kerosene, and also densified liquid oxygen into the Stage 1 and Stage 2 tanks. After a series of final launch vehicle checks, we will be ready for our targeted T0 and launch at 3:46 and 47 seconds a.m. Pacific time Thursday morning. To summarize, the Falcon 9 rocket and SWOT spacecraft are ready, and the launch team is prepared to launch this very important global water survey mission. Back to you, Megan.
Tim, thank you so much. Okay, Juliana.
Thank you. Thank you all. First, I want to start by thanking the whole team here, similar to Tim. It's an honor to be here today with the NASA headquarters team, the NASA Launch Services Program team, the NASA JPL team, the French Space Age, the CNES team, and Space Launch Delta 30. So it's an honor to be here today with all of you. As Tim mentioned, we successfully completed a static fire test on Friday evening. After that static fire test, many of you may have seen there was a bit of some weather in California. People often think about rain in Florida, but not so much rain in California. But here we are, and Californians were happy with it. But as part of the standard checkouts we do on the launch vehicle, we check to confirm there isn't any moisture intrusion in the engines on our vehicle. As part of those standard checks, we did see on 2 of our engines a signature that there is some moisture in 2 of those engines. What we're doing in partnership with the NASA Launch Service Program team, we are working to confirm what fluid is in those engines, if it's water from the storm or another fluid. So if it is water from the storm, we will work in partnership with NASA to prepare for launch when we're in a position to do so tomorrow morning at 3:46 a.m. likely. If it is something other than water, we would need to stand down on the launch and remove and replace those engines to ensure that we launch reliably. So that's a little bit on the issue that Tim mentioned. After a successful liftoff of the SWOT mission, we will be recovering the first stage booster. So for those local on the Central Coast, I did want to let you know that you might hear a couple sonic booms quite early in the morning. So yeah, excited about that. Hopefully it doesn't wake you guys up too much. And I just wanted to say on behalf of all of the SpaceX team, we're really, really proud to support so many of the NASA science missions, especially SWOT. We have such a long partnership with the JPL, the CNES, and the NASA team, and we're really proud to support such a cool science mission like SWOT. So thank you very much.
Juliana, thank you so much. We will now transition to the spacecraft team, as Juliana had said. So Parag, why don't you take it away?
Sure. Thanks. So I'm Parag Vaze. I'm with JPL. I'm the project manager for SWOT and have been the project manager since day one. It's a long time coming. I think we've been developing and working on the concept for almost 20 years. And NASA, as Karen describes, takes on challenging missions. We take on challenging missions to solve global problems. And water is one of those global problems, and water unites all of us. And between the U.S. and Europe, we have been working on this concept for more than 20, 30, 40 years, as Karen said. So SWOT is the culmination of all of those efforts from our scientists, engineers, and management teams really working together to be able to form this mission and bring it to reality. So it's a long journey that we come up against, and now the last part of it, frankly, is actually the development preparation of the satellite, although that has had its share of challenges, which we have worked together between the U.S. and French team to solve every step of the way to get to this point today. So I want to show you, kind of illustrate a little bit of that. Maybe if you can put up the first graphic of our more recent journey. You can see that we started the development of the I would say core part of the scientific portion of the spacecraft, which we call the Payload module, in the U.S. with contributions from the CNES and UK Space Agency and the Canadian Space Agency and at JPL, where we integrated the full payload. But that was the start of its journey. We developed it, tested it, and then we actually packaged it up, shipped it to France, and then continued its journey. You can see in this graphic on the bottom left, Tim showed us arriving, but even well before that, we made our journey to Europe first, and then spent about 14 months in Europe at the facilities of Thales Alenia Space, actually putting together our contributions, and CNES has thankfully contributed what we call the spacecraft bus or spacecraft platform that was put together. And then as we went through a long series of tests and checkouts of the satellite, eventually brought that back here to the United States for a beautiful launch on a SpaceX Falcon 9 rocket, and that itself was challenging in putting together all of the teams, the logistics, transportation, et cetera, to get to this point. And Tim showed a beautiful shot, I think, of us arriving here, and bottom left is a shot of us arriving on the U.S. Air Force C-5 that NASA supplied to get this pretty large spacecraft and all of the support equipment over to Vandenberg Space Force Base here, that we now have started over the last 2 months, done our final campaign to check out the spacecraft and get it ready for launch. So you can see on the next page, I think Tim already showed this, maybe on the next graphic, the satellite in its final configuration just before we said our goodbyes, and wishing it well in the encapsulated fairing of the Falcon 9. The spacecraft has been checked. It's in good health, and we just finished some last checks during the night, and we're really looking forward to continuing its journey off into space and really making the first part of the realization of SWOT, which is really getting up into launch in orbit and starting to produce that important data, which we expect is going to be transformational in many different fields, and really develop that next generation of measurements and information ultimately to help solve our global societal problems that I know Karen is dedicated towards helping support. So I'm going to continue maybe and hand it off to my partner, Thierry Laflamme, and he'll talk a bit more about that journey and more details on the spacecraft.
Go ahead, Jerry.
Okay, thank you, Parag. Same as Parag, I've been working and I've been lucky to work on this mission since day one. That's unique. And Parag and I, we pretty well know every detail of that mission, the hardware, the mission, the operations, and so on. So let me give you some information about the payload. The first slide will show some of the instruments on board the satellite. So the payload basically is comprised of two parts. The one is the what we call the Nadir payload, which is a classical Nadir suite of instruments that have been already flown on other altimetry missions, but comprising a radar altimeter. We see here we see some pictures, the Doris system, which provides accurate information about the satellite position in space, which is of prime importance, of course, to determine the water height. And the main instrument of the mission, which is, of course, the carrying instrument, the breakthrough instrument that will help providing these brand new data that we are all expecting. Carrying is a unique instrument, is a wide swath radar interferometer, and it's probably the flagship for a new generation of altimeters in space. So this payload was built by JPL and delivered in France. in June 21. Then we integrate, as I have prepared some patchwork of views of the integration of the satellite. So the satellite integration began in August 21. It was a 14-month effort, a complicated effort because this payload is unique. We have a very big spacecraft with new procedures and so on, but we went through. And I would like to emphasize also that we had to face the COVID period. That was something we didn't expect, of course. And we had to manage that very specific period. Again, as I said, thanks of the close cooperation, the resilience efforts of everybody, we were able to recover, to resume the activities in time and not jeopardize the schedule. So that was a unique way to show how these teams are working close together. The satellite, which is actually which was built by Thales Alenia Space. Thales Alenia Space provided the platform, and Thales Alenia Space performed all the integration and test activities in their premises in Cannes for 14 months effort without major anomalies. So after that, we were able to ship. Thanks to NASA providing a C5, because we had another problem to fix, which was the unavailability of the standard Antonov planes that we use generally, that were not available because of the Ukrainian crisis. So we had a solution that helped us meet the schedule. That was also another problem we didn't thought we had to face. After that, we came to the pad and do our own activities. Everything went okay. We did all the checks, and the spacecraft is ready to go today. And at this point, I'd like to emphasize also that, okay, we'll send the spacecraft in space. It will be a small journey for it. And then we have all the teams in Toulouse that will take over the responsibility of that baby, a newborn baby in space. And I'm sure the hundred of people that have worked, as you can see on the next slide, people in the main control room are working day after day to make things, of course, the smoother as it is possible for the next 7 days. We have the first 7 days that are very critical to get everything set in place. And of course, we are starting for 3.5 years of operations and providing the whole world a new set of unique data for a better understanding of our climate change impacts.
It's exciting to see what you guys will hopefully soon accomplish, so that's wonderful. Okay, and last but not least, Captain Rush, we had some stormy weather this past weekend. How are we looking for launch?
Yeah, we're looking great. As you mentioned, the weather was pretty bad this past weekend, and after that, we've seen a nice cull. This mission in particular, it obviously affects my career field directly, so we're really excited to be here and to help this mission along and into space. So if we can bring up the satellite shot, I can show you what we're looking at right now. As that storm has moved past, we are pretty clear looking out there right now. We do see a little bit of cirrus clouds over the water, and if anything, that's going to make the launch look pretty cool, because the rocket punching through the thin cirrus clouds, it could create like an O-ring, and then it looks pretty nice. I know a lot of people are going to be watching this launch, and then the landing as well, of course. So that's going to be a great show, hopefully for us this morning. If we go to the next chart, I can show you the official forecast that we have for launch. We're pretty clear. We're just looking at the cirrus clouds that are up at around 19,000 feet. Visibility is going to be great, as I mentioned, so we're going to be able to see the launch and landing well. If we could bring up the primary day and the next chart. And temperature, it's a little cold out there. I don't know, it's California, but we're seeing that it's pretty cold here in December too. So this is the Central Coast. It's a little bit different. Winds are going to be super light, and we're looking at a go percentage of 100% for weather. And backup day is looking very, very similar. With the upper level cirrus clouds, visibility is going to be fairly good as well. And winds are going to be light, 100% go for backup day as well. And that's all I have. We're excited to be here. So thanks, Megan.
You had some great news. 2 days, 100% go. Yeah, that's wonderful. Okay, so thank you, everyone, for those opening remarks. We're now going to take questions from reporters. Please keep it to one question and try to address who you want to answer that question. For those who just joined us in the room, raise your hand whenever you're ready to ask a question. Those on the phone, remember you have to get into the question queue by dialing *1. And then those on social media, your hashtag to use is a hashtag #AskNASA. Okay, so let's start with one on the phone. We have Stephen Clark, Spaceflight Now.
Tim Dine. Curious about the target orbit for this mission for the insertion. What's the altitude and inclination for insertion of SWOT at deployment from the Falcon 9? And this is a question maybe a little bit in the weeds, but there's a launch hazard area notice that shows a kind of a trajectory out towards the southwest that doesn't really match with what I think the inclination is, 78 degrees for this mission. Is that an error, or is there some major dogleg maneuver? And if so, why is that the case?
Thank you, Stephen. Yes, so you are correct. There is a significant dogleg. So our initial trajectory out of Vandenberg is going to be southwesterly, but we will be turning, making that dogleg a little bit left after that. As far as the orbital parameters, Parag, do you know your orbital altitude?
850 kilometers, 78 degrees inclination.
Yep. Did you get that, Stephen? 850 kilometers.
78 degrees.
78 degrees. Yeah, you were correct on the inclination of the once inserted into orbit.
And thanks, Tim. Why is that dogleg there for this mission?
I think, Juliana, do you know specifically? I can get back with you, Stephen, on the specifics, but I think that helps us clear some concerns about when we depart Vandenberg. We do have excess performance using Falcon 9 with the SWOT payload, and we're probably using that to make our launch probabilities better in regards to things like launch day debris risk and the flyback.
Thank you. The next person on the phone is Mike Wall, Space.com.
Thank you all for doing this. This would probably be for Karen. Could you just talk about are there any kind of satellites in NASA's stable of Earth observation missions that have a similar capability to this, of what SWOT can do, or is this something that's really brand new and is going to provide like an entirely new data set for you guys? Thank you.
Yeah, thank you for that question. So we've been doing satellite altimetry, measuring sea surface height for 30 years, and that's a big part of the record we rely on to understand climate change, for example. But what SWOT will do is give us a tenfold improvement in the fidelity, the spatial resolution of our measurements of water height. So, excuse me, if you think of normal satellite imagery, tells us where the water is. An altimeter tells us how high it is, and so we know how much water is there. Well, with SWOT, with this increased spatial resolution, what that really means is a few important things. The first one is we'll be able to see detail in eddies and currents and circulation in the oceans that we've never been able to see before. Along our coastlines, because we have that fine spatial resolution, we'll be able to see changes along our coastline that are happening because of rising seas. And then inland, with reservoirs, lakes, and rivers, we'll be able to see water bodies that we've never been able to see before. So think about putting on glasses. We will have a crisp picture of these inland water bodies and how much water is there. So globally, we'll go from being able to see a couple thousand inland water bodies, lakes and reservoirs, to millions. So an enormous positive impact for those who rely on knowledge of water levels inland to manage water for everything from agriculture to human consumption.
Very impressive, and thank you, Mike, for that question. Next person on the phone, Jeff Faust with Space News.
Good afternoon. A question for Juliana. You mentioned that if the moisture is not water that you're seeing in the engines, you have to replace them. Just curious, what other possibilities are there for that moisture? And if you have to remove and replace those engines, what sort of delay are we looking at?
Okay. Thank you, Jeff. And I think I caught the end of your question, so I'll seek to address both aspects. First, when we look at what fluid might be in the engines, in addition to the potential of water, we could see RP1 or rocket-grade kerosene or isopar, which is one of the fluids we use during the refurbishment process on our engines. So that's the first part. As far as what schedule impact we would see for engine remove and replace, I can't give any specifics at this time, but we are looking on the order of many days. It's not something that would be a quick, on the hour fix, something we could make our current primary or backup launch date.
Okay, thank you, Joanne. We have some questions from social now. Can we get a mic over to Allison here?
Hi, Troy from Twitter has a two-part question. The first part is, when is first light? And then when will data be available to the public?
Maybe I can take that. Yeah. So, as actually Terry was describing, the SWOT science payload has our brand new Karen instrument, but also has other traditional altimetry instruments that we've flown on past satellites, as Karen mentioned. So there's an heritage portion that we know quite well, and we know how to commission it well, and we know how to produce the data pretty well. So that portion of the payload, we should start and have it activated by the end of January, and start having some, I would say, first light results by middle of February timeframe. In terms of getting that data out, SWOT has a unique operational plan. So the first 6 months of the mission from launch, we're actually launching into a unique calibration validation orbit. It's specifically designed so that we're able to commission and understand the behavior of the instrumentation, and then move into our science orbit, which is a little bit higher, 891 kilometers, same inclination, where we'll start a more consistent repeat of the globe every 21 days, collecting data. The reason I mentioned all of that is because we'll actually start our science mission about 6 months after launch, and we'll start producing products from that period forward. The Nader payload products will start getting released to the public, I think around launch plus 9-10 months in that time order, and we're looking towards a similar target for our new payload, which is the Karen instrument, with more, I would say, checked and validated products in the launch plus 14-month period. Yeah. Do you want to say anything else? No.
Okay, let's do another social question.
All right. Betty from Twitter wants to know, what are the benefits of tracking water?
Well, there's so many. There are so many important benefits, but I'll mention just a few. In our coastal communities, actually, let me back up a step. So one of the things that we're seeing with the warming climate is an enhancement of the water cycle. And that generally means that in many places that have water, they're seeing even more. And in many places that are drier, it's getting even drier. So in those areas where too much water is a problem, SWOT will help us understand how that water is moving, and get better at predicting when there may be inundation, whether it's flooding in a coastal community from a storm surge, or vulnerability to flooding due to severe weather inland. In areas where the climate is getting drier. There, managing water as a resource is the challenge. And so these very high fidelity measurements of how much water is in the reservoirs and lakes and rivers can be a really critical piece of information for smart management of water, whether that's for food production or, again, just to support local communities.
Water is an ever-changing resource, and it's one of our most important resources, so
That's
it's important
right.
to track. Let's go back on the phone now. We have Stephen Clark again. He has a follow-up question.
I think my question's for Parag. I think you answered some of it about the commissioning, but can you talk specifically about the early days of the mission, how that timeline will play out with first acquisition of the signal, and then also critically the deployment of the antennas?
Maybe, what was your question? You want to know more about those first few days?
Yeah, I think you wanted.
Right, how that timeline will play out.
Okay, I'm sorry, just to be clear.
Deployment.
Yeah, so first of all, after we have our beautiful separation from the rocket, we'll go through basically about a 3-hour period, let's say, in an automatic mode, so that we can first acquire telemetry from the satellite, and then importantly have the solar arrays deployed so that we can check that the basic health and safety of the satellite look good and that we're power positive. So we expect to do that roughly in about 3 hours. And then, as Thierry described, the satellite controllers in France will really be continuing the process of checking out the basic functions of the satellite, and particularly the platform in terms of the basic capabilities of the platform. And then we kind of move, starting right from about day 4, into an important period for our new instrument, the Karen instrument, where we'll start the antenna deployment. The antenna deployment is a multi-part deployment. It's a first-of-a-kind design that we have that'll take place over the course of about 4 days. So we plan to do it step by step, carefully. But roughly about launch plus 8 days, maybe 8-9 days, we expect to finish this important activity and then move back towards our nominal orientation towards the sun, and then start the rest of the turn on and commissioning of the spacecraft. Did I answer your question?
It does. And do you have any cameras on board to monitor this, or is it all through telemetry?
Yeah, we have an interesting, let's say, add-on, which is a set of cameras that we have. We have 4 cameras mounted on the payload module. They are available to us, although we have plenty of other instrumentation to actually monitor the health, safety, and status of the spacecraft and the deployment. But we do have cameras that should be able to image the solar arrays on one side and also the antenna deployment after that. So we're expecting to have some beautiful imagery and also a movie of the antenna deployment in particular, and are expecting it to be a nice end-of-year present for all of us. Yeah.
That's a nice present. Yeah. Very unique present. Okay, we also have Lucy from AFP on the phone.
Hi, thanks for doing this. My question is for Thierry Lafont. I think you mentioned the lifetime of 3.5 years. Is this the requirement, and are you hoping for more than that? And also, if I may, I have a second question. Could you maybe expand a little bit on the main scientific instrument, Karen? Could you explain a little bit for the broad public, general audience, how it works? Thank you.
Okay. So for mission duration, of course, every time we launch a mission, we have to specify a mission duration. Here it's 42 months, of course, but everything on board has been really taken care of. And I can give you an example. The platform that has been designed by Thales Alenia Space is built against 10 years at least on orbit. So, of course, our system will not limit the lifetime of SWOT. And if everything is okay on board, certainly there will be an extension of the mission. 5 years is completely reachable, and many more years, as we've been doing since 30 years on our mission, that achieved more than around 10 years every time. So I can guarantee that we'll be able to make a long mission, because we need this data for a long time. With regard to the payload, as we said before, we have a classical nadir suite of instruments, which is the same as we use on the JSON series, on Sentinels, and the various Sentinels that provide the same measurement, like the DORIS instrument, precise orbit determination, the radiometer, which provide corrections of the water contents of the atmosphere, so that we can correct the radar signal that is sent to the ground. And of course the CARIN instrument, which is the brand new instrument. It's also a radar, basically. A radar is an instrument that sends a signal to the ground, and we receive back the echo. In this case, the particularity with CARIN is that the signal is sent by, you've seen all these antennas, impressive antennas, which are separated by a 10-meter base. So one of the antennas sends the radar signal to the ground, and the echo, reflected by the water surface, is then received by the two antennas at the same moment, or slightly deferred. And this is this measurement with the same signal received by the two antennas that provides such an accuracy for water detection and resolution. The other feature of this wide swath is that with these two antennas, we are able to cover a swath of 120 kilometers on the surface of the planet, which help us to cover the entirety of the whole surface of the planet, which is unique with regard to our past missions, which allowed only to measure under the trace of the altimeter on board.
Well, that was the last reporter on the phone, so if we don't have any questions here in the room, we're going to wrap up today's news conference. Thank you to everyone who asked questions for your interest, also for those who took time out of their day today to answer those questions. Again, liftoff is targeted for 3 a.m. Pacific time tomorrow, December 15th, and a live coverage will begin on nasa.gov/live at 3 a.m. Pacific time. And you can also watch on NASA's YouTube and social media channels. And for mission updates before and after launch, you can go to this website. It's blogs.nasa.gov/SWOT. Again, blogs.nasa.gov/SWOT. Thanks again for joining us. Go SWOT!